Hi everyone, good afternoon. I hope your exam went well, NMTC, the final round, right? So I'll be covering the junior paper now. Let's get started. Well, that's the first question. N and M are given to be positive integers. Find all such M and N so that M square plus 3N, okay, by the way, that's supposed to be M square in the question. So M square plus 3N and N square plus 3M are both perfect squares simultaneously. Quite a symmetric situation, right? Okay, so, well, let's think about this. M square and N square M square and N square are already perfect squares. To that you're adding something. So, well, let's first assume that M is less than equal to N. Yeah, maybe I can change the color. Yeah, so suppose M less than equal to N. In that case, what happens? Okay, first let's give these things some names. So you got M square plus 3N equal to, let's just call that A square. And then similarly, you have N square plus 3M is equal to B square, right? Now under this assumption, okay, by the way, I should probably say without loss of generality, we can assume M is less than equal to N, because if M comma N is a solution, then N comma M is also a solution, right? So we can just reflect the pairs and we'll get the other remaining solutions. All right, so what do we have? We have, okay, so N square plus M, 3 times M, what is that? That is B square. Now this quantity is greater than N square, because it is N square plus 3M, so it is greater than M square. And then it is less than equal to N square plus 3 times N this time. Because under the assumption M is less than equal to N, I can conclude that 3M will be less than equal to 3N. And that, by the way, is strictly less than N square plus 4N plus 4. Well, why am I thinking about that? It's because that's a perfect square. That's N plus 2 whole square. So what do we have? We have a chain of inequalities that says N square is less than B square, and that is less than N plus 2 whole square. So I can remove the square roots. That means N is less than B, less than N plus 2. So the only possibility is that B must be N plus 1. That's the only way, right? Because you're looking at an integer squeezed between 2 integers, and both of them, the gap is 2, so it should be the middle number. And that is N plus 1. Now let's just plug this information back and see what we get. So we have N square plus, by the way, what is that? N square plus 3M is equal to N plus 1 B square, which is N plus 1 whole square. And N plus 1 whole square, I can expand it as N square plus 2N plus 1. Right? So what does that give us? That gives us that N can be figured out in terms of M. That N is equal to 3 times M minus 1 divided by 2. And as soon as N is this value, this equation is already satisfied. So we need to go back to the first equation, right? Considering that the value of N is given by 3M minus 1 by 2. Okay. Ouch. Yeah, it would have been nicer if we had like an extra slide. But I hope, I'll give you a second to just think about all of this. All right, so let's continue. I'll start erasing few things. Okay, let's write that conclusion. We had n equal to 3 times m minus 1 divided by 2, right? So let's take that value and plug it in over here. We have m square plus 3 times 3m minus 1 by 2 is equal to a square. What is all of that now? It is m square plus 9m by 4 minus 3 by 2. Let's just write that is equal to a square. And you can complete the square. So what do we have? Ouch. So this is supposed to be 2. Right? Because 3 times 3 divided by 2, so that gives us that. And if you complete the square, you will say it is m plus half of the middle coefficient, 9 by 4. And then we'll have to adjust the constant term. So first let's remove the square of this quantity, which is 81 divided by 16 minus what do you really have? That is 3 by 2. And well, what is all of that? Times 8 times 8. So 81 plus 24, 105. Right? So we have, so let's clear the denominators. I'll multiply everywhere by 16. So I have 4a whole square is equal to 4m plus 9 whole square minus, yeah, that sum, 105. Which means you can write 4m plus 9 whole square minus 4a whole square is equal to 105. Ouch. Okay, so it's here now. Yeah, so now difference of two squares is 105. You can factorize this and work out the possibilities, right? So which one do I remove? I think I can remove all these things. I'll keep that. Okay, so what do we have? We have 4m plus 9 minus 4a times 4m plus 9 plus 4a is equal to 105. Now, what are the factors of 105? By the way, both these numbers need to be positive. It's actually clear that the right-hand side is positive because a and m are positive. And the left-hand side better be positive because the product of these two things is positive. So both quantities are positive. So what do we have? First, let's list down all the factors. We have 1. By the way, what is that number? It is 5 into 21. So that is 3 into 5 into 7. Right? So now that we have the factorization, you can work out all the divisors. 1, 3, 5, 7. Then you got 15. Then 21. 35. And the last one, right? 105. There needs to be 2 into 2 into 2, 8 divisors. 1, 2, 3, 4, that's 8. So these are the complementary divisors. So I don't know, maybe I'll just call this thing as P and this as Q. So let's notice few things. If I, okay, so first of all, P and Q are both congruent to 1 mod 8, right? So automatically I can remove a lot of options, okay, hopefully at least few options. So if you add these two things together, you get 4m plus 9, actually you get the double of that, is equal to p plus q divided by 2. So that tells us that m is p plus q minus 18 divided by, well, it was 2, now we also bring that 4, so that gives you excuse me, 8. Yeah, that's one thing. Oh yeah, so p and q are actually congruent to 1 mod 4, right? I mean, we'll use that if we need it. I think we'll need it, but I'll still save some space. And what's the other conclusion? If I subtract these two quantities, if I look at q minus p, what do I really get? Q minus p, these things will get cancelled. You're left with 8 times a. So divided by 8 is equal to a. So that says that p and q are congruent to each other, mod 8, right? That's one thing. And since both quantities are congruent to 1 mod 4, that tells us that this better be either 1 or 5 mod 8. So let's look at the possibilities. We have 105, then you got 3 with 35, 5 with 21, and 7 with 15. That doesn't look right. This also doesn't look right because it doesn't fit the congruence, right? I mean, you can just plug in all possibilities and you'll realize that you'll not get integer solutions, that's all. Okay, so what do we have? 105. So what does the value of m turn out to be in that case? M is p plus q minus 18 divided by 8. So what do we have? 106 minus 18 divided by 8, or the other value is 21 plus 5 minus 18 divided by 8. So 26 minus 18 divided by 8. So what are those two values? Well, that's 88 divided by 8. So 11 or 26 minus 18. That's 8 divided by 8. So 1. That's all. So these are the only two possibilities. I'm sorry, I'll just remove all of this. Okay, so m is equal to 1 or 11. And what does that give us? N must be, well, 3 times 1 minus 1 by 2, or 3 times 11 minus 1 by 2. And what are those two values? 3 minus 1, so that's 2 by 2, 1, and 33 minus 1 by 2. So 16, that corresponds to 11, and this corresponds to 1. So what are the solutions? 1 comma 1, therefore m comma n is equal to 1 comma 1 corresponding to this, or 11, 16. And if you remember, in the very beginning we assumed that m is less than or equal to n. If it's greater than n, you just have to flip all the coordinates. By the way, that gives you the same thing. So the solutions are, these are the solutions. That's all. Okay, I hope that was clear. And maybe I should also check that, but it's quite clear that it really satisfies all the things. Okay, next what do we have? PQR is a right angle triangle. So it's right at P, so let's just call that Q and R. Okay, I is the in-center of triangle PQR, so wherever that is. If you remember, in-center is the point of concurrence of the internal angle bisectors, right? So it should lie on the internal bisector of this 90 degrees, which means it must be 45 degrees over here, right? So I'll just call that I. By the way, if you just think of simple coordinates, I mean, I usually like coordinates when there's like 90 degrees. If there is another angle, I prefer to use some geometric facts. Since that's a 90 degree, it's quite convenient to use coordinates. Okay, now what's given? There's a line that passes through I. Let's say it's something like this, right? It hits these two lines PQ at A and PR at B. So let's just call this distance as little a and that as little b. By the way, that's my x-axis, that's my y-axis. So the origin is really P. So the x-intercept and y-intercept, those are those values. PQ and PR are small a and small b. So what do we have? We have the intercept formula for the line which passes through L. It looks like x by a plus y by b equal to 1. But what are the coordinates of R, of in-center? They are just r comma r, because this height over here, if you draw the circle, which touches all the sides, okay, that's not really touching that side, but this length is r, right? So the y coordinate is r, and since it's on the 45 degrees line, x and y coordinates are both equal to r. So let's take that information and plug it in this equation. What do you get? You get r by a plus r by b is equal to 1, right? And then divide the entire equation by r, you get 1 by a plus 1 by b is equal to 1 by r. That's all. And you know what, I'll just remove all of these. Let's just write one equation. So you have 1 by a plus 1 by b is equal to 1 by r. So if you apply the AMGM inequality, the arithmetic mean is greater than or equal to the geometric mean. So what does that give us? It gives us that 1 by a plus 1 by b divided by 2 is greater than or equal to square root of 1 by a into 1 by b. Let's work that out. So this is 1 by r divided by 2. So you have 1 by 2r is greater than or equal to, all of that is 1 by ab, the square root of the entire thing. So it is 1 by square root of ab, right? So if you flip this inequality around, if you take the reciprocals, you'll get 2r and square root of ab, but the inequality will flip. So 2r is less than or equal to ab, right? And that's all. Therefore, if you now you square both sides, you see that ab is greater than or equal to, I hope that's not confusing actually, yeah. You know what, let's actually write it that way. Yeah, so this root AB comes here, 2r goes there, right? So root AB is greater than or equal to 2r. Square both sides, you get a times b is greater than or equal to 4r square. And that's really what you want to prove, right? That it is greater than or equal to 4r square. I hope that's greater than equal to over there. Okay, pretty sweet. Comes out of AMGM and the simple relation that ties these two intercepts with R. All right? Okay. By the way, that's exactly what you wanted to prove. PA into PB, that's A times B greater than or equal to 4R square. All right. Next one. you want to solve for x, y, z. So let's just say that x, y, z are some real numbers. We don't know those numbers, but they are supposed to satisfy all those equations, right? So this one's actually pretty easy. All you can do is you can take x common from the first equation, and you get x plus y plus z minus 1 is equal to 7, right? And the next one, y into, what is all that? It is y plus z plus x minus 1 is minus 14. Notice that these two are actually the same thing, right? So you know what? Let's just call x plus y plus z as s. And the last equation is z times z plus x plus y minus 1 is equal to 49. So if you make that substitution, you'll immediately notice that x into s minus 1 is 7, y into s minus 1 is minus 14, z into s minus 1 is 49. Now if you add these three equations up, you can take s minus 1 common into x plus y plus z is equal to 7 minus 14 plus 49. Well, what is that? Minus 14, minus 7 plus 49. So that gives you s into s minus 1. Notice that this is actually s again, right? So s into s minus 1 is 42. That's a quadratic in s. So we can figure that out. By the way, the 42 you can break it down as 7 times 6. 7 into 7 minus 1. So 7 is a root of that. So 7 is a root. And the other root, well, if you expand that out, you see it is s square minus s. So the sum of roots is 1. So if 7 is a root, minus 6 is the other root. So those are the only two possibilities for the value of s. Okay, now that you have s, all you got to do is take those equations and plug in the value of s. So what do we have? Therefore, x comma y comma z is 7 divided by s minus 1 minus 14 divided by s minus 1 and 49 divided by s minus 1. So what does that give us? It gives us, well, there are two values for s, so we need to plug both those in, and then we get two different solutions. I'll just remove all these things. Oh yeah, so by the way, let's just write everything that we have learned till now. So s is equal to x plus y plus z, and the values that it takes, well, what was that? 7 and minus 6 were the two possible values. So let's take those things. When it is 7, what do you get? You get 7 divided by 6 minus 14 divided by 6. With a simple 2 cancel, you get minus 7 divided by 3 and 49 divided by 6. And the other solution is 7 divided by minus 6 minus 1, which is minus 7, right? And then minus 14 divided by minus 7, and then 49 divided by minus 7. So this solution, we can simplify that a bit. We could say that is minus 1, then 2, and minus 7. So these are the two solutions. Yeah, I hope that was clear. Yeah, this was a easy question, I would say. Okay, next one. What do we have? 28 integers are chosen from the interval 104 to 208. Prove that there exists two of them with a common prime divisor. I think this is a repeated question. I'm not fully sure about that. I'll have to check that, but I think that's a repeated question. Okay, so, well, you'll have to do this calculation by yourself. I'll just write down one thing. What I want to say is number of primes in 104 to 208, you'll have to actually count those things properly, right? Yeah, you can do that. So you can start counting, and well, if you really want to know if a number is prime or not, all you have to do is check the divisibility up to the square root of that number, and basically just pick the primes. Well, what's the biggest number that I can think of? Square root of 208. Well, that is less than square root of 225, which is 15. So less than 15, that's the only thing I need to worry about. How many primes are there? The primes up to 15 are, well, 2, 3, 5, 7, 11, and 13. Right? And then, well, you have 28 numbers. 28 numbers. Now what could happen is, maybe some of them are primes, but how many primes are really there in that interval? There are only 19 primes. Okay, so I can conclude that 28 minus 19, which is how much? 9. So I can say that there are at least 9 composite numbers. Right? So there are at least 9 composite numbers given any 28 integers in that interval. And every composite number, let's think about that. So if you have a number n, you can write it as product of smaller numbers. That's what composite means, right? So you can write them as a times b. Now check this out. And first of all, a and b should both be greater than 1. Now, if I assume that a is less than equal to b, then what happens? You see that a square is less than equal to ab. All I did is multiply by a on both sides. Now, ab is n. So the smaller number has to be less than equal to square root of n. Right? That justifies why we have to include only these primes. Okay, so now how many primes are there? There are 6 primes. So all these composite numbers, 9 composite numbers, there could be more. In fact, all of them could be composite. But at least 9 composite numbers, they'll have to be divisible with one of these 6 numbers. Pick any number in that list. It has to be either divisible by 2 or 3 or 5 or 7 or 11 or 13. Now, that's it. That's the end of the proof. Because by pigeonhole principle, what you can say is at least 2 of them must go in the same box. Yeah, so what does that really mean? I'm not sure if you're able to see that. Yeah, I can remove few things. You know what, let's actually remove everything that's below the line. Yeah, so there are 6 boxes. every composite number will have to be divisible by one of these things, one of these boxes. So whichever is the smallest prime that divides it, take that number and put it in that box. Now since there are at least 9 composite numbers, which means all these numbers will have to be either here. Okay, so the numbers which are divisible by 2, I'll put them in this box. The ones which are divisible by 3, I'll put them in that box. Whichever is the smallest, just put that in that box. You might say, all right, it could be divisible by both. I'll just put in the box 2. So 6 boxes, 9 pigeons. That means at least 2 of them must land in the same box. So landing in the same box, what does that mean? That means that those 2 numbers are divisible by the label of that box. It could be 2, it could be 3, whichever one of them. And this is the pigeonhole principle. That's it. I hope that was clear. Right? It's a combinatorial argument. But that's it. Yeah, this one's pretty interesting. You know what, I'll get back to this later. Because I didn't really do a good solution to this. You know what, let's do it right now. So you have, what do we have? The diagonal AC is perpendicular to the side AD, and ABCD is a parallelogram. So this is parallel to that, and this is parallel to this one. Yeah, I mean, I should have really thought about this, but I just went with coordinates, and that also gave me the solution. So I was fine with that. So let's call that point H, right? I think it needs to be said that H is on the side CD, but yeah. And then what else do we have? We have the circumcircle of DAB, right? So that will have the center, I don't know, I'll just call that O. Well, now what do we have? The next thing that's given is the tangent at D. Oops. The tangent at D to that circumcircle meets side AC, I mean the diagonal AC extended at point P. Now, yeah, that's an awkward angle. So PBA, this angle over there. Right. Maybe I'll draw that again. And then DBH. Okay, so this angle over here. So we want to show that these 2 angles are equal to each other. That's the goal. Okay, so I mean, you can actually take AC to be 1. I just called it A. So my definition is AC. You know what, let me just tell you, if I draw these 2 axes, it'll be very clear what I'm really doing. So that's X and that's Y. So this is A comma 0, and let's say that is 0 comma B. If that's the case, then A is the origin, and this point is A comma minus B. And you can work out the other points. Well, what do we really need? We want H. H, you can figure it out by saying, you know what, let's not put O right now. You'll need that O. Okay, so H, it satisfies X by A plus Y by B. So we are trying to solve for H now, right? That's the equation of this line, CD. And also, it's perpendicular to AH, right? So AH is perpendicular to CD, that's what I'm saying. So that slope will be y by x times the slope of CD, which is b by minus a is equal to minus 1. So that tells us that xa is equal to yb, right? So xa is equal to yb. So that tells you that x by a and y is how much? Xa by b. And there's one more b, so that's b square. So x is a square plus b square. No, x times a square plus b square divided by ab square is equal to 1. So the value of x is ab square divided by a square plus b square. So since we just have one slide, I'll erase a lot of things. But I hope that was clear. So all I did is I took the equation of line CD, and then the product of the slopes of two perpendicular lines must be minus 1. So AH is perpendicular to CD. That gave us the value of x. So H, yeah, let's just write it over here. The value of H, yeah, I should have also worked out the value of y, but that actually follows from symmetry. So H is AB square divided by A square plus B square, and then BA square by A square plus B square. So these things we'll just remove it now. Next, what do we need? P is something we need to figure out, right? Let's do that. So how do we do that? So first we can figure out the circumcircle of that. So the circumcircle will be x, the equation of circle looks like this: x square plus y square plus some linear term in x, some linear term in y, plus a constant is equal to 0. Right? But that constant has to be 0 because the circle passes through the origin. Right? And then the other points that it passes through is B and D. So let's plug in D, that looks easier. So if I plug in 0 comma B over here, I'll get B square, that's 0, plus U, okay, plus V times B is equal to 0. So that immediately tells us, by the way, you could have taken A to be 1, B to be K or something. That will make some equations look much nicer. So V is minus B. The other piece of information that we have is that the circle passes through the point B, which is A comma minus B. So let's plug that over there, and you get A square plus B square. Then you have plus AX minus V times B, right? But V itself is minus B, so that's plus B square is equal to 0. What does that give us? That's 2B square, and then ouch, that's supposed to be U. So what do we have? We have U is equal to minus of A square plus 2B square divided by A. So now what does the equation of that circle look like? It looks like, I'll just remove all these things. Let's record that. Let's keep that in mind. So value of V is minus B, value of U is that. So the equation of the circle now looks like minus A square plus 2B square by A x minus B y is equal to 0. So where's the center of the circle? The center of the circle is A square plus 2B square divided by 2A, it's half of that coordinate, and then B by 2. That's where the center of that circle is. Okay, I'll just remove these things again. Now we are ready to figure out the coordinates of P. How do we do that? If that's the center of the circle, then, okay, let's call that O. Then OD and PD will be perpendicular to each other, right? Because PD is a tangent. So once those things are perpendicular, you know what, let's call this minus alpha 0. I don't know the coordinates of P, so I'll just call it minus alpha 0. So alpha is the thing that we need. Yeah, by the way, I can also remove this. And what's the radius of the circle? It's just the sum of squares of these two quantities divided by 2. So due to lack of space, I'll just write the final answers over here. That's all. Okay, now P, the way you can get it is, well, product of slopes is -1, right? So the coordinates of O minus the coordinates of D. So let's do that. It is B by 2 minus that quantity, B by 2 minus B divided by A square plus 2B square by 2A minus 0, right? What is all that? That's the slope, first of all, that's the slope of OD times what? The slope of PD, and that's easy. That's B divided by alpha. B minus 0, 0 minus alpha, right? So this product needs to be -1. So the numerator, let's simplify these things now. The numerator is just minus B by 2. So let's remove that. Minus B by 2. You see that I can cancel 2 and 2 like that. And then what are we left with? This minus is also gone. So B square divided by, okay, so A also comes up. So we have B square A divided by alpha into A square plus 2B square is equal to +1. So the value of alpha, I can just write it over here. I can remove that. And that's the value of alpha, right? Okay. So now that we have this point, you know what, I'll just write it over here instead of writing it all over the place. So what is that coordinate? It is AB square divided by A square plus 2B square. Yeah, I guess there's a minus also. That's P. Yeah, I'm sure there's a really good solution for this. I just didn't think about that. Okay, so now we have pretty much everything that we need. Yeah, maybe except for this point. By the way, we can start calculating the tan of angle PBA, because that's one of the angles that we are interested in, angle PBA. And how do I calculate that? That is tan of, well, PBC minus ABC. PBC minus ABC. Right? Now, tan of A minus B, right? You say it is tan of the first angle, PBC, minus tan ABC divided by 1 plus the product of these two tan. And we can actually start calculating all these values. So let's plug that in. I don't know which one to remove. Okay, let's try this out. So tan PBC, what is all that? PBC. So it is PC divided by BC. So PC is A plus alpha. So it is A plus AB square divided by A square plus 2B square, whole thing divided by B. That's the first term. Minus tan of ABC. That's the easier one. That's just A by B. Divided by, yeah, I think you'll lose me if I write everything over here. Yeah, at least this part I hope is clear, right? So this is tan of PBC, which is A plus that value, and then whole thing divided by B. And then you subtract tan of ABC, which is A by B. So once you do that, the numerator already simplifies. It is AB square divided by this quantity. So I'll just write the final expression. Yeah, maybe over there. So tan PBC is that thing, AB square. Yeah, even here you can remove one B, right? So it is AB divided by A square plus 2B square, and the whole thing divided by 1 plus this quantity times that quantity. So it is A by B plus AB square by, yeah, so again AB by A square plus 2B square, then the whole thing multiplied by A by B. 1 plus tan A tan B, right? You can simplify this expression. Let's see what we get. So this factor cancels, right? Yeah, that's right. So that factor cancels, and you'll be left with A. You'll have B square. There's a B up there, so that B goes up. So you'll have AB cube divided by, yeah, I just remember this answer. I think it is A power 4 plus 2A square, yeah, 2A square B square plus 2A square B square. So that's 4A square B square plus 2B square. 2B power 4, I'm sorry. Yeah, 2B power 4. Yeah, I didn't really show you all the calculations, but that's the value of tan PBC. And also you can calculate in a similar way the value of tan DBH, just by saying it is DBC minus HBC, and you'll really get the same value. I'll leave that for you to think about it. I don't want to expand this because it's not really the nicest solution. But basically you can really compute both these values. What's the other angle? DBH, right? And once these two tan values are equal, the angles must be equal. So that's one way to verify this. This is more like a verification. It's fine, it's also a solution. Therefore, both the angles are equal to each other. Okay. Okay, let me quickly tell you what goes into calculating the other tan value. Well, you need DBC. To get DBC, you need to figure out this point. And then HBC. You'll also have to figure out that point, right? Basically, these two lengths you need to work out. Once you work those out, you'll get everything that you want. So I'll just stop over there with this question, just because it's not the most interesting way to do it. Yeah, so the proof idea, I've written it down. You can check the solution later. So these two values are computable. So tan of both these quantities, once you work those out, you'll get the equality of the angles, right? Okay, next one. Yeah, this one is slightly different. I felt like that you need some more information for this question. Okay, so let's just call the ages of all these friends, I'm going to call this as M, this as C. No surprise there, right? Manish, Kathy, Sundar, Elijah, Lakshman, L, and Divya. So let's write down good equations first. Manish told that the sum of our ages put together is 5 times my age. All right, so the first equation is M plus C plus S plus E plus L plus D is 5 times Manish's age. Right? So let's simplify that. I can remove M. That's all. That's the only simplification. And over here, you'll have 4M. That's the first piece of information in that line. He again told that when Sundar will be 3 times my present age. So what's really going on? So after some time, Sundar's age will be S plus T. And that is 3 times Manish's present age. So after how much time would that happen? That means T is 3M minus S. Okay, so at that time, sometime in the future I hope, the sum of my age and Divya's age. So my age meaning Manish, because Manish is the one speaking about all these things. Okay, so what do we have? M plus T, Manish's age, plus Divya's age, again at that time, will be equal to the sum of the present ages of the 5 of us. That's the catch. I mean, 5 of us. So which 5? If you notice, there are actually 6 friends over there. So 5 of us. So who's excluded? Well, there are not a lot of possibilities. The one, 5 of us. Clearly, you cannot exclude Manish, I hope, right? Because he's talking about all these things. Let me think about that. Okay, so sum of all those ages, so Manish plus M plus C plus S plus E plus L, right? Without Divya. Actually, it would have been better if that was more clear, but I think it's fine. Just think about both the possibilities. If Manish is the one excluded, what happens then? Then Divya is excluded, what happens then? You can also wonder, maybe Sundar is the one who's excluded, right? But in that case, I think you'll actually not get any solution. There are no positive solutions for all these ages. Anyway, so with this interpretation, so who's left behind except Divya, right? Yeah, so it will be equal to the sum of the present ages of the 5 of us. So that is that. And this I can write as sum of all the ages, which by the way was 5 times M minus Divya's age, right? So let's see what that equation gives us. It gives us, well, you also know the value of T. So you have M plus D plus 2 times T. 2 times T is 6M minus 2S is equal to 5M minus D. Now what is all that? 7M minus 5M. So 2M minus 2S is equal to, I don't know, maybe I'll bring that D also to this side. Let's bring everything to one side. If that D comes here, you'll have plus 2D is equal to 0, right? And 2 is common everywhere, so that's gone. So all of this is really just telling you that M, yeah, you know what, I'll remove all these things. Because it is just one single equation. Which is M plus D minus S is equal to 0, right? So before starting to solve, we need to write down good equations. So how much did we cover? Till here we are done. And Elijah's age will be 3 times her present age, meaning Elijah's age is E plus T, and that is 3 times her present age. Right? E plus T is 3 times E. So what does that give us? That is 2E, and T was how much? 3M minus S is equal to 2E. So that's that equation. Next, Lakshman's age will be twice Sundar's present age plus 1 year. Okay, so Lakshman's age is L plus T is equal to twice Sundar's current age plus 1. And what is all that? We have the value of T again. So I don't know, L plus 3M minus S is equal to 2S plus 1. Yeah, looks right. So L is all of that. Okay. And is there anything more we have? That's all, right? And now all these friends are starting to solve these equations. So let's write down which equations are really important. Okay, so this equation, I'll write it. I don't want to write this one. This I can remove. Ouch, did I erase that too early? What was that equation? Yeah, it was E plus T is equal to 3E. So T was 2E, but T itself, by the way, what was T? T itself was 3M minus S. So 3M minus S was equal to 2E. Yeah. 2M minus S is equal to 2E. Yeah, already that number's wrong. 3. That's right. That's the next equation. And the last equation over there is telling you I guess I can just remove this part. L is equal to 3S minus 3M plus 1. Now we can get rid of this equation. Excuse me. Yeah, so how do we start solving this thing? By the way, there are 6 variables, but only 4 equations. So that's really not enough. Okay. Yeah, let's try to solve it in terms of M and E. You see that S can be solved first. S is equal to 3M minus 2E. Next, we can go for D. What is D? D is S minus M. S goes there, M goes there, S minus M. And S is that quantity, so it is 2M minus 2E. And next, we can go for L. That is 3 times S minus M, but S minus M is 2 times M minus E, so 3 times that, so it will be 6 times M minus E plus 1. Right? So in terms of M and E, we could figure out S, D, and L. What's the one thing that's left? C, right? We can figure it out from the top equation. What does that give us? C plus S, which is 3M minus 2E, plus E, plus L, which is 6M minus 6E plus 1, and then D. D is 2M minus 2E. And all of that is equal to how much? All of that is equal to 4M. Right? Okay, so we can simplify that. How many m's do we have? 3m, 6m, 2m. So that is, yeah, and also minus 4 coming from the other side, right? So 6 plus 5 minus 4, so that is 6 plus 1, that is 7. So I'll write it over here. So we have C is, no, C plus yeah, how about I write it over here? So let's say M and E are given. So C plus 7M. Now how many E do we have? Minus 2 plus 1, so that's minus 1. Then minus 6, so that's minus 7. Then minus 2 more, so minus 9E. And then there's a constant, that's 1 is equal to 0. So now check this out. We could write all the ages in terms of M and E. Ouch. Now the only condition is, okay, so S I can send all these things to the other side. I'll have C is equal to 9E minus 7M minus 1, right? Now we can also get rid of these equations, because we've really solved the system in terms of M and D. So I guess Kathy was right. She said that Manish needs to tell something more, because that's not enough, right? But anyway, we can try a bit harder. All we got to say is, notice that all these numbers must be positive, right? So let's first write D must be positive. So yeah, at least greater than equal to 0, right? D must be positive. So that tells us that 2M must be greater than 2E. And that immediately tells us that M is greater than E. And also these numbers are positive, right? So M and E are positive and M is greater than E. That ensures that D is positive. Now as soon as M is greater than E, you see that 3M will also be greater than 2E, right? So S will automatically be greater than 0. Next, who's left? We can go for Lakshman. L is 6 times M minus E, but M minus E is again positive, so so L is also positive, right? So these three things we could ensure that. The last one, C, also has to be positive. So what does that give us? It says C greater than 0 means 9E must be greater than 7M plus 1, right? Sending the two terms to the other side of the inequality, you get 9E must be greater than that. Okay, so E must be greater than 7M plus 1 divided by 9. So these two inequalities are just enough, right? Because this inequality will ensure that C is greater than 0. The other inequality is implied by D greater than 0, and once it is true, all the other numbers will be greater than 0. So it's all positive ages. Okay, so let's patch these two things up. What do we get? So I'll remove all these things because I really don't want that. Yeah, so maybe I'll forget that inequality. Let's write that. So E must be so 7M plus 1 divided by 9 must be less than E, and E is supposed to be less than M. So I can say it is less than equal to M minus 1. And if I want to tighten this up, I can put the ceiling function and make that strict inequality into less than equal to. Okay. So since we have also captured this, I can remove that. That's all. So E must satisfy those two inequalities. I mean, it would have been nicer if the inequality was something different and you came up with a bound for M. That would have really cracked this problem in a unique way, but that somehow didn't happen. Okay. So what does that tell us? It tells us that 7m plus 1 must be less than 9m minus 9. And what does that tell us? It tells us that 2m must be greater than 10. So m is greater than 5. M is greater than 5. Now, you see, Kathy was right. Manish needs to tell something more. But the only thing he says is that his age is an odd number. So that could mean it is 7 or 9 or 11 or any of those numbers. So there are really many solutions to this problem. Okay, so let's catch that. We have m greater than 5. So that told us that m has to be at least 7, right? So let's just work that case. Suppose m was 7, then what does this inequality look like? 7 times m, so 7 times 7, so 50 plus, okay, that's 50, that's all. There's no plus, I already added it. Divided by 9 is less than e divided by 7 minus 1. So that's 6, okay, less than equal to, right? And what is that number? It is 4, okay, not 4, 5 point something, right? 45 is divisible. So 5 point whatever. But it has that this number e, an integer, has to be greater than 5 and less than equal to 6. That pins down e to be only 6. Okay. So that's e. It has to be 6 if m is 7. If m is 9, then you'll get other possibilities for the value of e. Okay, now let's plug those values over here. So we can work those out. So m, c, s, e, l, and d. So let's see what these values are now. You know what, maybe I'll just remove that. So let's record that fact over here. So e has to be 6 if m is, right? So now, what do we have? We have this expression over here is m, that's 7, then c. What is c? 9 times e minus 7 times m minus 1. So 9 times 6, 54, minus 7 times m, 49, minus 1. Then s. What do we know about s? 3m minus 2e, yeah, that was 6. Okay, so 3m minus 2e. And what's next? E is 6, right? So you know what, maybe I'll just calculate these values and write that over here. So 54 minus 50, that's just 4, right? Next, how much is all that? 20, yeah, I hope I got that right. 21 minus 12. So that is 9. Next, so we got 3 of these numbers, and yeah, e is anyway 6. Then L, what is L? It is 6 times m minus e. M minus e is 1. So 6 times that plus 1. So it is 7. And next, D. The value of D is 2 times m minus e. So that is 2. Ouch. I didn't know that. Divya was so young. Okay, that's a possible answer to that question. So how old are Manish and Sundar? Where is Manish? Manish is the first one, so that's 7. Then Sundar is 9. So 7, 9 is, at least if my interpretation is right, especially for this part, then that better be true. Okay. That's all. I mean, there are really many more solutions, but that really doesn't pin their ages down properly. Okay. Let's go to the next one. All right, so what do we have? X square. Ouch. All right. So x square minus y by 34x minus y square is equal to y by x. And more importantly, x and y are positive integers. Okay. So first things first, you send that there, you send this here. What happens? You get x cube minus xy is equal to 34xy minus y cube, meaning bring the y cube term to this side. You get x cube plus y cube is equal to 35xy. Right? So that's really the same as that. Fine, you also need to check that condition, but that's that. Okay, now let's say that x plus y is p and x times y is q. Right? Then x plus y whole cube, okay, x cube plus y cube will then be x plus y whole cube minus 3 times xy, x plus y. Standard identity. X plus y whole cube is x cube plus y cube plus this term, right? So now I can write this as p cube minus 3p cube. So what do we have? Therefore, p cube minus 3pq is equal to 35q. That's the equation in terms of p and q now. That was in terms of x and y. Now in terms of p and q, that's what that looks like. Okay, so you can take the 3pq to the other side, and that will give you p cube. You can take q common, and then 3p plus 35. So what's the value of q? P cube divided by 3p plus 35. I hope that's clear. I haven't done much, but the value of q can exactly be figured out in terms of p. So I want to erase all of this. I'll just keep this over here, right? Yeah, so I'll try to remember that. P cube, that's easy to remember. 3p plus 35. Okay. So q is equal to p cube by 3p plus 35, right? Okay. Now, one more thing, right? I mean, if you look at that, you'll say x and y are roots of this quadratic. So since they are natural numbers and all that, at least the discriminant must be a good number, right? In fact, it must be a perfect square. So the first things first, let's just write down the inequality. By the way, there are more ways to get that. Yeah, so let's not involve a quadratic. I can just write x minus y whole square as x plus y whole square minus 4 times xy. Now what is all that? That is p square minus 4 times q. By the way, that's the discriminant of the quadratic that I just wrote. So this better be greater than or equal to 0. And what does that tell us? It tells us that p square must be greater than or equal to 4q, but 4q is 4p cube divided by 3p plus 35. Yeah, let's make some cancellations. P square, that's p cube, so 1p is left. And what you have is 3p plus 35 is greater than or equal to 4p. So bring that 3p here, you see that p is less than or equal to 35, or 35 is greater than or equal to p. Same story, right? So I'll remove all these things now. I'll put that over there. Let's write that conclusion. P is less than or equal to 35. Okay, that's good. So that will ensure that the discriminant and all that works out fine. But now, we never really use the fact that x and y are natural numbers. Let's use that now. So x and y are natural numbers means that p and q should also be natural numbers, because that's a sum of two natural numbers, that's the product of two natural numbers. So both p and q are natural numbers. Ensuring that p is a natural number, there's nothing hard about that. But this quantity must be a natural number, right? So 3p must divide, okay, 3p plus 35 must divide p cube. This is a very common scenario. So whenever you have a rational function in one variable, the most natural thing to do is actually do the division, right? And you'll be left with a remainder term, which will be a constant number divided by this. So the denominator has to divide that constant number. Or else we could do it more number theoretically. So I can say that 3p plus 35 has to divide 3p whole cube. Because if it divides p cube, it also divides 3p whole cube, which is 27 times this number, p cube. And that quantity, we can write it as 3p plus 35 minus 35. Think of this as one number, and then whole cube. What does that look like? That's like a minus b whole cube. So it has a cube minus 3a square b plus 3ab square minus b cube. Now all the terms except that minus b cube have a, meaning all those terms will be divisible by 3p plus 35. So I conclude that 3p plus 35 has to divide the last term, which is 35 cube. Right? Because if you make that expansion out, you'll see that the first three terms are actually divisible by 3p plus 35. In fact, that was the whole reason why we wrote 3p like that. Right? And now what is that number? It is 5 cube into 7 cube. Okay, so 3p plus 35, I mean, what kind of a number are we really thinking about? So 3p plus 35, we have some bounds coming from here. So first things first, that is greater than 35. I mean, I can also say it is greater than something much more, because p has to be at least 2. So that must be greater than 35 plus 6, in fact. Anyway, so it's at least greater than 35. And now, thanks to this discriminant criterion, you get it will be less than or equal to 3 times 35 plus this 35, which is 4 times 35, and that is 140. Okay, so let's write that over here. I'll remove all these things. I'll just want to write the final conclusion. Okay, so yeah, fine. I mean, I really want to just write this. Is there a way to move this thing around? Let's see. No, not that. Okay, let me not mess with that. I think this is good enough. So, okay, so what do we have? Yeah, I'm just writing these two conditions. You know what, I also want to remove the first line. At least this part. You know what, why not both of them? Okay, so let's write this thing. Ouch. Okay, and then I'm writing all of that over here. You know what, maybe I shouldn't do that. So 3p plus 35 divides 5 cube into 7 cube, and also this number is at least 36, right? I mean, it's much more than that, but it's at least 36 and at most 140. So now I can happily remove these two lines. Okay. I mean, I've written nothing more than what was already written. Okay, so we can think of all factors of this number, right? Basically, we want only those factors which are between 36 and 140. I mean, if you're not very... okay, I'll just write down all the factors. So I wanted to write 5 square. Phi cube. You know what? Maybe I'll really write all the factors. So 7 times phi, 7 times phi square, and also 7, right? Then 7 times phi cube, then 7 square, ouch, 7 square, 7 square times phi, 7 square times phi square, 7 square times phi cube, and then the last line, 7 cube times phi, 7 cube times phi square, and 7 cube times phi cube. Anyway, they are all the factors, positive factors, but we really didn't have to write all of that, because we need to ensure that the factor of that we are interested in must be between 36 and 140. So at least, you know what, these numbers I can knock them off. 7 cube, that's a huge number. So all these things are gone. And what else is left? By the way, these are too small. 1, 5, phi square. So at least phi cube is left. Then 7 is again too small. That's exactly 35, but we want more than 35. Then what else do we have? By the way, let's knock some big numbers out. That's 125 into 7 square. That's too big for us. And then 35 square. That's also too big, right? Then 49 times phi. Again, we have crossed the threshold. Then 7 square. That looks okay. Then 7 times 25. 6 times 25 itself is 150. So we have crossed that. So this number is not allowed. Once that is not allowed, this is also not allowed. Therefore, 3p plus 35 must be either, okay, the only solutions that we got are phi square, phi cube, and 7 square. So now we can also remove this. Okay, so what does that give us? By the way, what are these numbers? These are 125 and 49. So that tells us that 3p must be how much? 125 minus 35, 90, or 49 minus 35, that is 14. Now again, that should be divisible by 3, which means 14 is also not allowed. Therefore, P is equal to 30. That's it. So P is equal to 30. Now we can work out Q and everything that we are interested in. So Q is P cube divided by 3 times P plus 35. By the way, 3 times P plus 35, that's actually 5 cube in this case. So 30 divided by 5 whole cube, which is 6 cube. Right? Now let's remove all these things. Let's write the final conclusion over here. P equal to 30, just like that. And then Q is equal to how much? 6 cube. Yeah, you can set up a quadratic and work out the values of x and y now. I don't know, I find it convenient to work out x minus y whole square, because that's really the discriminant, right? So P square minus 4 times Q. And what is that in this context? It is P square means 30 square minus 4 times Q, which is 6 cube. So, well, we can take 6 square common. We are left with 5 square minus 4 times 6. 5 square is 25, that's 24, so that is 1, which means this is 6 square. So x minus y whole square is 6 square. So that tells us that x minus y is either 6 or minus 6. Right? So I guess we can remove this one now. By the way, now you really have everything, right? X plus y is 30 because that's P and P is 30. And now x minus y is 6. That's the first case. What does that give us? Yeah, just add those two equations. 2x is equal to 36, so x is 18. Once x is 18, x minus y is 6, so y is 12. The other case, you'll get that, you'll get 12 and 18, right? So that's all. Ouch. Therefore, x comma y is 18 comma 12 or 12 comma 18. Right? You see that the difference is actually minus 6 in that case. So that's it. They are the only solutions to this puzzle. Okay. And by the way, 34 times x is not equal to y square, right? I mean, basically there is a 17 over there. There is no 17 on the other side. Okay, good. So let's go to the last question now. We have ABC is an acute angle triangle. ABC is an acute angle triangle, and then O and H are these points, the circumcenter and the orthocenter. The altitude from A, okay, let's first look at this thing. So what do we have? We have A, B, and C. The altitude from A, meaning this one, right? You drop a perpendicular from A to the opposite edge. Maybe you'll have to extend the line also, but that's the altitude. Then the perpendicular bisector of the side AC. Perpendicular bisector of the side AC means these two are equal to each other, and that's 90 degrees. And the side BC, these three lines are concurrent. Well, what does that mean? So AB, AD, that's the altitude. Okay, so if they are meeting, they better meet at that point itself, right? So I'll just call that D and E. Okay, because where else can they meet? AD and BC, they meet at D. So the DE itself must be perpendicular to AC, right? Now, notice these two triangles. These two triangles, they're actually congruent to each other, right? Because AE is equal to EC. Let's write that down. AED. I'm claiming that this triangle is congruent to CED. Why is that? Because these two sides are equal. Then ED is the common side, and angle E is 90 degrees. So SAS, side, angle, side, and the angle is the included angle. So that's good. So what you can conclude now is that AD must be equal to CD. The other corresponding parts must be equal to each other. So AD is equal to CD. So what is that really telling you? It's telling you that triangle ACD is right isosceles. And where is it right? It is right at D. And once that is isosceles, that means that this angle over here must be 45 degrees. Therefore, angle C is 45 degrees. That's the first conclusion. In fact, that's equivalent to all of that, right? So the only conclusion that you can bring out of this is that angle C is 45 degrees. Now let's find that thing. What do we want? Okay, I guess I'll have to erase this. So I hope this much is clear, right? Basically, angle C is 45 degrees. So let's just mark that, and everything else, I'll just forget about that. Yeah, so angle C is 45 degrees. Now what do we want? We want some other quantity, CH divided by BO. Okay, let's work through that. By the way, there are ready-made formulas for all these things. BO means the distance between the point B to the circumcenter. So this quantity over here, that's actually R. That's the radius of the circumcircle, right? Circumradius. And now, how does that look like? 45 degrees? I guess it does. So H, now we'll have to figure out, okay, where do you think H will be? H will be over there, right? So A, B, C. And what we want to find is CH. How do we do that? There are really many ways to do that. I guess, yeah, why not? You can first figure this length out using this triangle. Which triangle am I talking about? You know what? Let's call that P. and Q. So PC divided by, okay, so PC I can actually find, divided by AC. So which triangle am I looking at? I'm looking at triangle APC is right at P. APC, this triangle, is the right vertex is P. So I can look at PC divided by AC and say that that is the cosine of that angle, angle C. Is that right? And AC is usually called B. So this quantity usually denoted by small letter b. So what does that give us? It tells us that PC is equal to B times cos C. That's not enough. I mean, we know C, but we don't know B. All right, now where do we go next? Now look at triangle HPC. That's again right at this vertex, right? The right vertex is P again. So now let's do this. Okay, I don't want, I guess I can remove these things now. Okay, so what do we have? PC divided by CH, which by the way is the quantity of interest, right? CH is something we really care about. So PC divided by CH. What is all that now? Yeah, so I'm looking at this triangle, right? So I can say it is, oops. Yeah, there. So it is cosine of angle PCH. Right? I'm looking at this triangle. So PCH, if I look at the cosine of that angle, it will be the adjacent side PC divided by the hypotenuse CH. So what does that give us? By the way, we also need to know that angle, right? So PC we actually know, which is B cos C divided by CH. What is all that now? It is cosine. Now check this out. I can write it as, well, what is that angle? PCH. So I can write that as B CR. Right? It's really the same angle. I'm extending these 2 points. That's all. But now that quantity I can write it as 90 degrees minus angle B. How am I getting that conclusion? I'm looking at this triangle. Angle R is 90 degrees, and then the other two angles must add up to 90 degrees, right? So cosine of 90 minus B, what should that be? That is sine of B. So let's put these things together. What did we get? Yeah, so CH, yeah, so B cos C divided by CH is equal to sine B. Therefore, CH is equal to B cos C divided by sine B. You might notice this quantity over here. There's this rule called the sine rule, and the sine rule says that B by sine B is actually equal to twice capital R. Right? It's equal to the circumdiameter. And then cos angle C. That's all. So this quantity, we could now figure it out. It is 2R cos C. Therefore, CH divided by BO is 2R cos C divided by R. What's all that? It is just 2 times cos 45 degrees, right? And cos 45 degrees is 1 by root 2. So 2 times 1 by root 2, so that is root 2. And that's the answer to that question. Good. Okay. Yeah. Thanks a lot for having the patience to come to this point. Yeah. Okay. So that's all, I guess. Thank you so much.